we are going to use today's class to look at lesson 5.03 because this week we have 5.03 and 5.04. If you've looked in Buzz on the grade screen, it tells you what's due this week. 5.03, geometric sequences lesson, and then we have the geometric series lesson. So what we're going to do is today we're going to go over 5.03, and Thursday we're going to go over 5.04. So that way we'll just kind of break it up. Neither class will be very long to give you time to go and work on those assignments during that class period if you like, because you'll have time to do that because we won't be in here forever. But we'll review both of these. Last week we did the arithmetic sequences and the arithmetic series, and we're doing geometric this week. So it's a little bit different, but it's the same type of concept as far as how that goes. So, all right. So we could have some further ado if you like, or with no further ado, we can move into the lesson. So let me put up my camera on here and let's talk about what a geometric series or sequence is. And we'll compare it to what last week. Now, see, last week we had arithmetic sequences. An arithmetic series. So an arithmetic sequence, just to recall, would be like 1, 4, 7, 10, ... right? So we know it had a common difference, and that difference, like in this sequence here, would be 3. It's a plus 3. We could even say more accurately, it's a plus 3. Every time to get from one number to the next, you just add 3. Very simple. Very simple. But what if our sequence was this? Let's go 1, 4, 16, 64. Obviously not an arithmetic sequence. It's not adding the same number each time. It starts like our original one, but instead it's doing something different. What's it doing? What's happening with our sequence here? Try to get everybody this morning. Multiplying by 4. Thank you, Abraham. So it's times 4 each number. So 1 times 4 is 4, times 4 is 16, times 4 is 64, and that's what it's doing. So this was a common difference. For geometric, it's a common ratio. So we will call it R equals 4 because the common ratio is being multiplied each time. And sometimes it may be a little tricky to recognize. We could have a sequence that starts at -1 and goes to 3 and -9 and 27. And you look at that like, wait a minute, it's going from positives to negatives, positives. Is that a geometric? It's not arithmetic, but is that a geometric sequence? If you don't know what's going on, just do the math. Take this. We know it's not arithmetic, so we don't have to subtract or add or anything. Take this and divide it by this. So what's 27 divided by -9? And is that the same as -9 divided by 3? And is that the same as 3 divided by -1? Okay, you just take a term and divide it by the term in front of it. And if these are the same every time, then we know this is a geometric sequence, and that will tell us what our ratio is. So what is 27 divided by -9? What is -9 divided by 3? What is 3 divided by -1? You can use a calculator, none if you like. 27 divided by -9. Yeah, you guys are getting in the chat. -3. And not -9 divided by 3 is also -3. 3 divided by -1 is also -3. So this is a common ratio of -3. It is a geometric sequence. Get that calculator out of the way. It has a common ratio of -3. So geometric sequences they can go positive, negative, positive, negative, positive, negative, as long as it's consistent. If it went -9, -27, now this is no longer a geometric sequence. It's just random. It's a random sequence. Because it would go a negative, negative, positive, negative, negative. Could not do that and be a geometric sequence, but it could do negative, positive, or positive, negative, however it starts. Okay. So it's just recognizing a geometric sequence. Now, we talked about last time there is a recursive formula to help find a term in a sequence. We did that for arithmetic, and it will also be one for geometric. So if we want to know what a sub n is, and a sub n is whatever term. So let's say we want to know what I'll use this one for example. We want to know what the fifth term is for this sequence. Well, it has a common ratio of 4. So all we have to do is take what the ratio is, 4, and multiply it by a sub n minus 1. In other words, if we want to know the fifth term, all we got to do is take 4 times whatever the fourth term is, a sub 4. Whatever the fourth term is, take it times the common ratio, and that tells us what the fifth term is. So I guess generically, the recursive formula would be a sub n equals the ratio times a sub n minus 1. That is for any and every geometric sequence. That is the recursive formula. Take the ratio times whatever the term before is. So in this case, a sub 5 equals 4 times this term is 64. So a sub 5 equals 256. A sub 5 is 256 because we just take the term before it and multiply it by the common ratio. And we're like, okay, that's great. It's nice to have a formula to use for that. But what about when we want to know the 15th term instead of the 5th term? Hopefully we've got an explicit formula, right? Because otherwise I'm going to go ahead and have to find a sub 5, a sub 6, a sub 7, a sub 8, a sub 9. I got to keep going all the way to a sub 14 before I can calculate what a sub 15 is. So if I want to know what a sub 15 is for this sequence again, same sequence up there, 1, 4, 16, 64, we need to know what is the explicit formula. Well, there is an explicit formula, and it is a sub n equals, again, we have to know what the first term is. What is a sub 1 times r to the power of n minus 1? Like, whoa. Okay, let's highlight that. So we'll get that in our notes. So if you want to know for geometric sequences, for geometric sequences, there's your formulas for your notes that you can use on tests and assignments and everything. So this says if I want to know the 15th term, I can take a sub 1, which our first term in this was 1, times the common ratio, which we calculated was 4 to the power of n minus 1, 14, right? Oh, I just put in minus 1 parentheses. I don't need the parentheses if I'm just going to put it as the power. 4 to the 14th power. Okay, let's get that calculator back out here. Clear everything. 4 to the power of 14. 4 to the 14th power It's big. The 15th term is 268,435,456 because we're multiplying by 4. So the next term will be over a billion because a sub 16 is 4 times that number. Big number. 268,435,456. Aren't we glad we didn't have to do recursive because those would be dealing with bigger and bigger numbers times 4 each time. But that is the explicit formula. So it's just a matter of recognizing what do you need? You need a sub 1. You need R. You need a sub n minus 1 if you're using the recursive formula. Right? And R would be raised to the power of n minus 1. So these are the main numbers you need to know. What is n? What is n minus 1? Of course, n is just whichever term you're looking for. If I'm looking for the 15th term in this sequence, we can take n minus 1 once we know n. A sub 1 is always the first term. They don't always start with 1 or negative 1. Let's look at another one. Let's look at another sequence here. Let's say we have 2, all right, 2, negative 6, 18, negative 54, ... Okay, this is similar to one that I already used as an example because 2 to negative 6 that's multiplying by negative 3. Negative 6 times negative 3 is 18. 18 times negative 3. So again, our common difference is negative 3. A sub 1 this time is 2. So if we want to find the 11th term, a sub 11, using our explicit formula, we take 2 times negative 3 to the 10th. 2, that's our a sub 1, times r to the n negative 1. R is negative 3 to the 10th power, since this is 11. All right, so let's do negative 3 raised to the power of 10. There you go. Negative 3 to the 10th is that times 2. So it says a sub 11 is 118098. Seems simple enough. See, when you get into the lesson, it's got our lesson summary. It talks about those two different recursive and explicit. There's that explicit formula right there, the geometric sequence formula. A sub n equals a sub 1 times r to the n minus 1. Again, the domain is restricted to integers equal to or greater than 1, natural or counting numbers. When we have the domain, we're talking about the n's, right? N's, a sub n. This has to be 1 or greater. We can't find the 0th term. Has to be integers. We can't find the 1.6 term. It has to be an integer. It has to be 1 or greater. So we're limited on our domain. But again, the range can be anything, right? It can be positive numbers, it can be negative numbers. The range, there's no limit to the range, but we are limited on the domain. The range is unrestricted. So the combination of this is a combination of functions because we're taking the constant function a1 and we're multiplying it by the exponential function r equals n minus 1. So that's pretty much the summary of the lesson, what we have right there. You can go through, it's got lots of different examples in here. It explains things a little more detailed than what I did. I was just giving you some extra examples. Oh, here's one that says, identify the 14th term of a sequence where a sub 1 is 6 and a sub 8 is negative 4, 6, 8, 750. That's a good one because they didn't tell you what the common ratio is, and they didn't give you two consecutive terms. So let's go through that example. To find R, when all we know is the first term and the eighth term. Let's look at that example. We're going to have to calculate the common ratio. We need to know the 14th term, but we have to know the common ratio between the first and the eighth. So you can use the sequence we have and say A sub 8 equals this. So here, let me write this on paper so we can go over this together. I'm gonna move this over to the screen. There we go. All right. So let's step through this. We know that the first term is 6. We know the eighth term is negative 468,750. Okay, and we want to know the 14th term. Okay, so we need to find that. So let's look at, since we know the eighth term, A eighth would be A sub 1 times R to the 7th. Right, take the first term times R to the 7th. We can start substituting what we know for that. So A sub 8 is negative 468,750. And it's going to equal the first term, 6 times R to the 7th. Right, 6 times R to the 7th. So to solve this, let's divide both sides by 6 to get the R. Try to get the R by itself here. So this will tell us essentially what the 7th term is. So this is negative 78,125 is R to the 7th term. So how you find that is, if this was, let's just use 25 equals R squared, and we needed to know what R was, we would take the square root of each side, and R would equal plus or minus 5 in this case. All right, because we take the square root because this is squared. Well, since this is to the 7th power, we have to take the 7th root of both sides. So let's see if our calculator, this is a very simple calculator we have. Let's see if it'll do that to that level here. Let's see. This is the square root. Let's see what other options we have on there. If I expand the calculator, does it add functions? Sometimes we add functions on there. It's actually all right, so we won't use this calculator to do it. Let's use this calculator. We can just put it in Google and use that calculator. 7th root of negative 78,125. Type in Google, let it do it. There it is. Calculator's correct. The root of the 7th degree to 78,125 is equal to 5. And that equals, so our R is negative 5. So we can find our 14th. A to the 14th equals A to the first, which was 6, times negative 5 to the 13th. And that one we can do with our calculator here on the computer. Because we can do negative 5 raised to the 13th power and take that times 6. So it's negative 7,324,218,750. That's what a to the 14th is. But this is the type of work you got to do when they don't tell you. Oh, let me get that out of the way. When they don't tell you what the R is, they just tell you two terms. You got to do a little algebra, set it up with our formula, a to the 8th would be equal a1 times r7, since we know what the 8th term is, and then work backwards to get that. So it's a big number. All right. That's all we're gonna mess with. We're not gonna get into the next lesson until next class on Thursday. So Thursday we will look at the geometric series. So we looked at the geometric sequence. So we'll look at 5.03. We will look at 5.04 on Thursday's class. So anyone have any questions? Have any questions on 5.01 and 5.02? That was what was due Sunday night. So if you have any questions on that, I know a lot of you guys had that done earlier in the week. So that's fabulous. Fabulous. So, all right. Well, if there's no questions, I will let you guys go until Thursday. So Thursday I'll see you and we'll go over 5.04. So have a wonderful time until then.